Hey guys, happy Monday. We were gonna take notes today, so go get your notebook, go get a pencil, pause the video while you get set up, and I'll meet you back here. All right. So make sure you're taking good notes because you're gonna have a little mini quiz on Friday, and you can use your notebook on the quiz because I'm not there to stop you. So make sure you're taking good notes, copy everything down so you have examples for your quiz. Okay. So let's go ahead and title our notes 9.1.1. 9.1.1 Solving Inequalities. Okay, let's get started. So let's look at this from last week. So last week is when we started inequalities, right? So we have an inequality here that says x is greater than 2. Go ahead and copy that down. Anytime you need extra time writing, just pause the video at any point so you can write down what you need to and then resume play after. So feel free to pause the video as much as possible. Okay, so this inequality here says x is greater than 2, right? We're going to solve this inequality right here. So what this inequality is really asking for is all the numbers greater than 2, right? So let's see what types of solutions we can get. So right off the bat, let me give you one answer. X is equal to 3. Now the reason 3 is a solution is because 3 is greater than 2, right? So that's why 3 is a solution. So that's one answer. Another solution is 4, because 4 is greater than 2. Does that make sense? 5 is greater than 2, so it's a solution. 5.5 is greater than 2, so that's a solution. 1,627 is a solution, because 1,627 is greater than 2, right? These are all examples of solutions to our inequality right here. Now, there are an infinite number of solutions to this inequality, right? These 5 are not the only solutions. So the way that we show every single solution is by graphing it on a number line. So go ahead and copy the number line. We're going to graph it. So remember, it's all the numbers greater than 2. So that means we're not going to include 2 as a solution because 2 is not greater than 2. So we're going to put an open circle at 2, like that. See the open circle? And I'm going to highlight all of the solutions. So that means 2.1 is a solution, 2.5, 2.6, 3, 4, 5, 6, 7, 8, 9, 10, 1,627, all the way to infinity. Any number greater than 2 is a solution to our inequality. Cool? Okay, so let's take it up a level. This is like the easy level. Let's go to a medium level. Ready? So go ahead and write down this inequality. X plus 3 is less than or equal to 10. So as you can see, I already have one solution written there. X equals 5. Now the reason 5 is a solution is because if we plug in a 5 right here, 5 plus 3 is going to be less than or equal to 10. Watch, I'll show the work. 5 plus 3 is less than or equal to 10. And we know that 5 plus 3 is 8. And is 8 less than or equal to 10? Yes, it is. Perfect. That's why 5 was a solution. Okay, another solution to this inequality is 7. So let's plug in a 7 right here. 7 plus 3. Let me show my work. 7 plus 3 is 10. And is 10 less than or equal to 10? Yes, 10 is equal to 10. So that's why 7 was a solution. Okay, another solution to this inequality is a negative 3. So let's plug in a negative 3 in front right here. Negative 3 plus 3 is 0. And 0, is that less than or equal to 10? Yes, it is. So that's why negative 3 was a solution. So just like I said before, there's an infinite number of solutions, right? These are not the only 3 solutions to this inequality. But I want to show you an example of one that is not a solution. So let's try plugging in 8, the number 8. Okay, so we're going to try plugging in an 8 right here. So let's look at 8 plus 3. 8 plus 3 is 11. But is 11 less than or equal to 10? No, it's not. So that's why 8 was not a solution. Does that make sense? So again, there's an infinite number of solutions, and I don't know what the rest of the solutions are. I guess I could just keep making up numbers like we did up here, but there's an actual way that we can solve this inequality. So let me show you how. So pause the video if you're not caught up, go back and copy anything you need to copy, take your time, and then push play when you are ready. All right. So the way that we solve an inequality is the same way that we would solve an equation. So if, as you can see, I have x plus 3 equals 10 compared to x plus 3 is less than or equal to 10. All I did was I changed the inequality for an equal sign because we know how to solve that equation on the left, right? Go ahead and copy it down if you haven't. Okay. First, we always build a little barrier, right? And then our goal is to get x by itself. But right now, x has a 3 being added onto it. So we need to do the opposite, right? Instead of a plus 3, we're going to do a minus 3 to make those 3's cancel out. Now, 10 minus 3 is 7, so x equals 7, right? We all know how to solve that equation, but what's really cool is inequalities are the exact same. We're going to solve the inequality the exact same way. Step 1, build a barrier. Our goal is to get x by itself, so I need to get rid of that plus 3. So I'm going to subtract 3 on both sides. The 3's cancel, and I get 7. But it's not x equals 7. See that inequality symbol? I'm going to copy it down below, and my answer is x is less than or equal to 7. That means our solutions to this inequality are all the numbers less than or equal to 7. So like on the previous page, remember how we said -3 was a solution, right? And we had a bunch of answers. All the numbers less than or equal to 7. 6 is a solution, 5 is a solution, 4 is a solution, -3 was a solution, -647 is a solution. Any number less than 7 will make this inequality true. So let's make a number line and graph the inequality to show all of the solutions. Set up a number line. Now it says less than or equal to 7. So that means 7 is also a solution. So I'm going to put a closed dot at 7. A closed dot at 7 and highlight all the numbers less than or equal to 7. Cool? Whew. All right. So we're going to do a total of 5 examples. And I'm going to consider this example number 1, right? So we have 4 more examples, just so you know. All right, let's do example 2. Write it down. So now we're going to do the same thing, right? We're going to start step 1, always build a barrier. Now our goal is to get x by itself, right? I currently see that there's a -5, and I see that there's a 2 being multiplied to x. So our first step, always start farther away from the x. I need to get rid of that -5. So I'm going to do the opposite and say +5. I want to add 5 on both sides. The 5's cancel. And then let me write down what's left. 2x is greater than or equal to 8. Notice how I brought down that inequality symbol. Okay, now if you see right here, the x is currently being multiplied times 2. So what's the opposite of times? Divide. So you divide by 2 on both sides to make the 2's cancel. And we get x is greater than or equal to 4. So that means the solutions to this inequality are all the numbers greater than or equal to 4. Go ahead and set up a number line. Let's graph all of our solutions. Greater than or equal to 4 means you're going to put a closed dot at 4 right there, and you're going to highlight all of the numbers greater than or equal to 4. Closed dot, highlight everything greater than or equal to 4. All of those numbers are solutions. All right, good job. Whew. All right, example 3, you ready? This one you're going to do on your own. I lied, not this one. You're going to do a different one on your own. I think we're still doing this one together. Okay, go ahead and copy this guide down. Oh, I was right. Okay, yes, you're doing this one on your own. And then you're going to type your answer into Edpuzzle for me. Go ahead and solve. Okay. Now, when I did it, I got all the numbers less than 2 are solutions. Did you get the same? All right. We're stepping the difficulty up one more level. Let's go. Okay. So we have 2 more examples left, and these 2 are hard ones. So go ahead and copy this guy down and get ready. We're going to do the exact same thing. Step 1, build your barrier. I currently see that there's a plus 3, and there's that negative 2 that's being multiplied by the x. So I need to get rid of both of those. I'm going to start with that plus 3. I'm going to do the opposite and subtract 3 on both sides. 3's cancel, and we have negative 2x is less than negative 2. Now we currently have this negative 2 being multiplied by the x, so do the opposite and divide that guy away, right? The negative 2's cancel over here, and we have x is less than 1, right? So right now I'm saying the solution is x is less than 1. That means all the numbers less than 1. Now I'm going to tell you right now that the reason why this problem is harder is that's actually not the right answer. And I'll show you why. I'm going to check one of the solutions. So we're saying all the numbers less than 1 should be solutions to that inequality, right? So let me check a number that is less than 1. I have it on the side right here. I'm going to check the solution 0 because 0 is less than 1, right? So what I'm going to do is I'm going to take that 0 and I'm going to plug it back into the inequality to check to see if it comes out true. So I'm going to plug it in right there for x. So instead of it being negative 2 times x, it's going to be negative 2 times 0. You see that down there? Negative 2 times 0. And then I copied the rest. Plus 3 is less than 1. Okay? Now that negative 2 times 0 is 0. So 0 plus 3 is 3. And is 3 less than 1? The last time I checked, it wasn't. That is not true. So that means our original solution, right? Our original solution right here, all numbers less than 1, that is also wrong. And I'll tell you why. This is what made this problem tricky. Do you see right here when we divided both sides by negative 2? At that step right there, there's a rule with inequalities that if you ever multiply or divide both sides by a negative number, like we did here, then you have to change this inequality and flip it to go in the other direction. So instead of being less than 1, it's now greater than 1. All of the numbers greater than 1 are the actual real solutions to that inequality. I know that sounds super crazy. Okay, so I want you to make sure you wrote this down. And then I want you to write down this rule. Whenever you multiply or divide by a negative number on both sides of the inequality, you must flip the inequality symbol. Write it down and go ahead and box it, highlight it, put stars, put a cloud around it, do what you gotta do so it stands out in your notes. And then we have one more practice example. All right, here we go. I want you to try this one right here. I want you to solve this one on your own and write your answer in Edpuzzle. So copy it down, solve it, be careful, this one's tricky, and let's see what you get. Okay, so I got x is less than or equal to -6. See how it started out as greater than or equal to, right? It was still greater than or equal to, but right here at this point, we divided both sides of the inequality by a negative number. So then I had to switch the inequality. I had to flip it in the other direction. So now it says less than or equal to when it started out as greater than or equal to. Did you see that? Did you do that right when you did it? Okay, last thing, let's graph our solutions just to have good practice on that. So go ahead and set yourself up a number line. And we are graphing our solutions, all the numbers less than or equal to -6. Go ahead and do it. That's what I got. Did you get the same? If you did, awesome. Okay, so make sure you have all your notes written down. You will have a mini quiz on Friday. So thanks for sticking in with me. Be safe, stay healthy, and I will see you guys later. Bye.